All right, example number 2 says a man pushes 100 newtons on the handle of a 40-kilogram lawnmower. The applied force is in the same direction as the handle, which is tilted 35 degrees relative to the horizontal. The coefficient of kinetic friction is 0.1. Find the amount of acceleration. So first and foremost, I'm just going to write down my givens and draw a picture. And before I do that, can we just take a moment and appreciate that stock photo that I found online? Yeah, I don't know either. So we know that the applied force is equal to 100 newtons. The mass of the lawnmower is 40 kilograms. And then we also know that angle, it's tilted at 35 degrees relative to the horizontal, which I will draw into my triangle. And then we know that the coefficient of friction is 0.1. And again, coefficient of friction is unitless, so that's why I don't put units on it. Now, if we draw this lawnmower like this, I can see that my applied force is down at that angle right here of 35 degrees. So let's break down that applied force vector into x and y components before we actually draw a free body diagram. So drawing that angle, that force at an angle a little bit bigger, I know that this is my 100 newtons of force, and then I know that my applied force in the y direction is down, and my applied force in the x direction is to the right. So solving for my applied force in the y and the x direction, let's do y first. Applied force in the y direction is equal to 100 newtons times the sine of 35, which is equal to 57.36. And then the applied force in the x direction is equal to 100 newtons times the cosine of 35, which is 81.92. Whoa, that was weird. Newtons. Made like a perfect circle. That's crazy. Okay, so now we've broken down that vector into x and y components. Let's draw our new free body diagram. So here is my lawnmower. I know that the applied force in the y direction is down. I also know that I have the force of gravity down. My applied force in the x direction is to the right. My friction force is to the left because it opposes the motion. And then finally, my normal force is up. So I know that I'm solving for acceleration here. So using Newton's second law in the horizontal x direction, because that's the direction of acceleration, we get net force is equal to mass times acceleration in the x direction. Net force I'm going to call right positive because that's the direction of the applied force in the x direction. So I get force applied in the x direction minus the force of friction equals mass times acceleration. Now, I know the force applied in the x direction. I know the mass of the lawnmower. I'm looking for the acceleration, but I don't know what the force of friction is yet. But I do know the equation for the force of friction. So you can do this one of two ways. You can either plug the equation into this equation for the force of friction, or we can solve for the force of friction first and then plug it in. I'm actually going to solve for the force of friction first, just because it's a little complicated and I don't want my big Newton's second law equation to get too crazy. So force of friction, I know, is mu times the normal force. Now we know that this lawnmower is accelerating horizontally. It has no acceleration vertically, right? It's not moving up or down at all. So there's no vertical acceleration, which means that forces are balanced in that y direction, which tells us that this normal force right here is equal to the applied force in the y direction plus the force of gravity. So I can plug that in now. I get force of friction is equal to mu times the quantity, the applied force in the y direction plus the force of gravity. Okay, again, because forces are balanced in the vertical direction. So I also know that the force of gravity is equal to mass times the acceleration of gravity. So I'm going to plug that in as well and then plug in my numbers. So I get force of friction equals mu times the quantity, force applied in the y direction, plus mass times acceleration of gravity. Plugging in our numbers, we get mu, which was 0.1, times the quantity, force applied in the y direction, which was 57.36 newtons, plus mass of the lawnmower, which was 40 kilograms, times the acceleration of gravity, 9.8 meters per second squared. So I'm going to do everything in the parentheses first. 40 times 9.8 plus 57.36, and then multiply that by 0.1. So I get the force of friction is equal to 44.936 newtons. And now I can take that number and plug it into my original equation. So first and foremost, in this Newton's second law equation, I'm going to divide both sides by mass so that we get acceleration by itself, because we know that that's what we're solving for. And we get acceleration is equal to force applied in the x direction, which was 81.92 newtons, minus the force of friction, which was 44.936 newtons, and then divided by mass, which was 40 kilograms. So we get 81.92 minus the answer, divided by 40, and we end up getting acceleration is 0.925 meters per second squared.